I have one question about the email I sent you. I never got those answers. Do you have them for the um?
The answers for what? I'm sorry.
Do you have those answers for the page 471 problem?
Yes, I can send it to you.
All right.
Let's see. I'll pull that up. I was pulling up the textbook page and I'll email it while we're on. Other questions?
What does it mean by like solve for the right triangle for 4 through 12?
It means get all three angles and all three sides.
Okay, thank you.
Uh-huh. We can work one of those together if y'all want, or if you want to try it, then I can tell you if you got it.
Could you do number 4?
Sure. So, Christian, give me a minute on that, okay?
Yeah, no problem.
Sorry, it's coming up. It's just loading the page. All right. Okay, can you see it?
Yes.
Okay, so number 4, when you solve it, this is where you use those rules or tools that we wrote on the board, and you look at what you're given and figure out which of those can help you finish this triangle.
Okay.
Different people start different places. Usually, I start with the triangle sum because that's the easiest. And in number 4, you can actually start there because you already know 2 angles, the 90 and the 37. So how much is angle P?
53.
Mm-hmm. Let me see if I can make it bigger. Let's see. Oh, yeah, there we go. All right, so now you've got all the angles, and you know one side. And if they give you one angle, like they gave us R, we could use P now that we know it, but we'll just stick with R. And we know 22. What part of the triangle is 22?
The hypotenuse.
Mm-hmm. You can find either of the legs because the hypotenuse is part of both of the sine and cosine ratios.
Okay.
So, like if you're an angle R, QR, the bottom of it, would be your adjacent, and QP would be your opposite. So you can use whichever sine or cosine, whichever you like, to find one of those sides first. So how would you go about it?
I would do sine equals x over 22. Or
Sine
sine
37 x over 22.
Yes.
To find either one, right? Because sine is opposite over adjacent. So that would be making this x. Okay. All right. And then, I forgot to grab my calculator, but that's all right. What would you do to solve that?
You would multiply by 22, like sine 37 by 22.
Mm-hmm. Yep. I'm going to grab my calculator real quick, and I'll be right back, okay? Well, actually, I got my phone. I think my phone has that kind of calculator. I'm not sure. Let's see. Yeah. Okay. So what did you get when you multiplied that?
I got 13.2.
You got it. Very good. So that's x. And then you have options for QR for the bottom of it. Because you know two of the sides now, if you know two sides, how can you find the third?
Pythagorean theorem.
Mm-hmm. So you can do Pythagorean, that's one option. Or
Could
just
you
like,
also do like cosine, like for your opposite angle? Because we found that. Could you also do like adjacent angle, which would be which could be like your new x, which is on the long leg, or yeah, you could do like cosine through that.
yeah, you could. I'll use a different variable just because we used x. So this down here could be y, like that. You mean? Yeah. So cosine of angle r, because if you're doing cosine, it's adjacent over hypotenuse. So y would be your adjacent. Your hypotenuse is still 22. So then you'd put that in your calculator. And what'd you get?
1 second. I'm typing it in.
Okay.
I got 17.6.
Yeah.
So yeah.
17.6. So now you have solved the right triangle. You have all three sides and all three angles.
Okay.
When you do this on a quiz or test, how I have it right now, like I have labeled the sides that we're missing like that. It's okay if you just label your triangle like that. It might give you like blanks to the side. Just be sure if it gives you blanks to the side, you're real clear about what's what. Like if you were going to list this, you would say, Q P is 13.2. Measure of angle P is 53. Like that. You would list it out. Does that make sense?
Yes, ma'am.
Okay.
So we do need to list it out.
It's okay with me if you just label it on the triangle as long as it's clear about what goes with what. I mean, even though mine's messy, I can tell that 53 is in that top angle, 13.2 is on that left side, and 17.6 is on the bottom. So as long as it's clear where the stuff goes, that's fine to just do it on the triangle.
All right, cool.
Other questions?
Can we do a few more from this section, like number 5?
Uh-huh.
Thank you.
All right, number 5, each of these, you have the same tools, but you have different information you start with. So you might use a different tool first or differently. And number 5, you know two sides of the triangle. How can you find the side that's missing?
Pythagorean
Yeah.
theorem.
Yeah. Anytime it's a right triangle, if you know two sides, you can find the one missing with Pythagorean. So in number 5, is it one of the legs or the hypotenuse that's missing?
The hypotenuse.
So I'm going to make that X. And remember, it's just good habit because of how this book arranges some things to put that on the left side by itself. And then the other two on the right.
You could solve this like by Pythagorean because you also solve it the way we did like the cosine thing.
Not to get a side of the triangle.
Okay.
The cosine thing will help you get a side if you know one of the angles. Like in number 4, we knew that 37. But you don't know anything but the 90. So you have to, well, you could find an angle first, which we're going to do in a second. Well, it's okay. It's just a different way to go about it. Kind of like a proof. I told y'all, there's different directions to get you to the same spot.
Yeah.
If you did that to find an angle first, then you could, after you find an angle, use either sine, cosine, or tangent to find the leg or the hypotenuse. All right, with this one, let's see, this is 121 plus 224. And then take the square root of that. Let's see. All right, what'd you get?
X squared equals 445, but we have to wait. We do the roots.
Mm-hmm.
Right? Yeah, okay. So I got 21.09502311.
Mm-hmm. Which one? And it wants us to round to the nearest tenth was the instructions. So 21.1.
Yeah.
All right, so that's the length of the hypotenuse. So now we've got all three sides, and we need to get some angles. We have one angle, the right angle. What's the tool that helps you find angles?
I was thinking like 45, 45, 90, but you couldn't do that in this case. You could.
No, because you don't know that if two sides were the same, like if they were both 11, the two legs, then yeah, that would work. But because the two legs aren't the same, 45, 45, 90 won't help.
Yeah.
So if it's not a special one, to get the angles, you have to do the inverse trig, what we learned at the very beginning on that right side board yesterday.
Okay.
So remember, you set it up on your paper, but then your calculator does the work.
Yeah.
So let's see. Let's find P first. It doesn't matter, but we'll just go for P first. So it's fine to use this decimal we just got, but in order to keep your answer like as accurate as you can, since we know we rounded that decimal, let's use the 11 and the 18 so that we won't be dealing with that stuff we've already rounded. Does that make sense to everybody?
Yes, ma'am.
Okay. So if angle P is what you're trying for, that's your perspective, then what is 11? What kind of part of the triangle is that?
Because we have to find P and N. For P is the adjacent. For N, it's the opposite.
Yes. I'll do two different colors. So P is going to be this purplish, pinkish, whatever. So it's adjacent. What's 18 for P?
For P, it's opposite.
All right, I'll go ahead and label with another color just so we're ready. When we're doing angle N, you said that 11 is the opposite, which makes 18 the adjacent, right?
Yes, ma'am.
Okay, y'all good with my color code? What goes with what?
Yes, ma'am.
All right. So for P, back to P, if you want to find angle P and you know opposite and adjacent, which of the trig functions uses opposite and adjacent?
Tangent.
Tangent, yep. So tangent P is going to use that opposite over adjacent. And for this angle P, we don't know it, so I'm going to put that little -1 thing because that means we're looking for the angle. What are our numbers for opposite and adjacent in this triangle for P?
Tangent P equals 18 over 21.1.
Oh.
Just
Yeah.
kidding. I lied to you.
What's your adjacent? We labeled it.
Oh, we're finding adjacent. Sorry. Wait. We only use opposite. Like, I kind of get confused with this sometimes. When we're finding opposite, we go to sine, but if we're finding tangent or cosine, it's adjacent.
I'm not sure I 100% understand how you asked it.
Yeah,
But-
I don't even.
But here's the actual ratios never change. It's
Okay.
sine is opposite over hypotenuse. Cosine
Yeah, I got it now.
is adjacent over hypotenuse. And tangent is opposite over adjacent. So the reason in number 5 that we're going for tangent is because if we're at angle P, if that's what we're trying to find, 11 and 18 are whole numbers. There's no decimals with them. So if we use those two numbers, it's going to keep us from rounding again. Every time you round, it kind of cheapens your answer, I guess is a way to say it. Makes it not as strong of an answer every time you round. So if we were using 11 and 18 from angle P, we decided that was our adjacent and our opposite. That's the purplish pink label, the adjacent opposite. So opposite and adjacent are always tangent, so we know we have to use tangent. You with me so far?
I solved it out already, and I got 58.6.
Let's see. I backed up, so I haven't punched it in. Let's see. So when you punched it in, you did second.
I did second tangent, then I did open parenthesis 18 divided by 11 closing parenthesis, and I got 58.6.
You did it exactly right. Good.
Yay.
All right, so I'm going to label that in my triangle. Like I said, you can list these out on an answer blank or something if it gives you that way. But so there's 58.6 degrees down there. To get angle N, you have two options.
Okay.
One of them, we've labeled in red how you could do something using inverse trig, which is what I'm going to do because it's new and I want us to practice it. But what's another way you could find angle N?
Do that'd be sine.
Like the triangle sum.
Yeah, triangle sum is another way you can do it. Sine would work, but you'd be using a decimal. But if you use triangle sum, you know that this is 90, this is 58.6. So you could add those two and subtract from 180. Does that make sense?
Yes, ma'am.
Right. But just because it's new and I want us to practice it, I'm going to use the inverse function again.
Is that on the quiz tomorrow or no?
Yes. The quiz tomorrow is the rest of the chapter, 7.5, 7.6, 7.7.
Okay, cool.
So it's sine, cosine, tangent, inverse, and then solve right triangle, which is kind of everything all together.
Yeah.
Like these. All right, so if we're trying to get N, and from N, we labeled that 11 is the opposite, 18 is the adjacent. Just a minute ago, we decided that tangent always uses opposite over adjacent. So we want tangent again so that we can use 11 and 18. It's not wrong to use 21.1 and use one of the functions that uses hypotenuse. Like I said, it's just your answer is not as strong if you do that.
Yeah.
So opposite over adjacent for angle N would be 11 over 18, which is that negative. I'll go ahead and just write it there. That negative function, the inverse. So in your calculator, second tangent, this time 11 divided by 18. What'd you get?
31.4.
Yep. All right. Anybody have questions about, there's lots of steps about number 5?
No, ma'am.
No?
No, I'm good.
All right. You understood it okay?
Yeah.
All right. Anna or Christian, do y'all have other questions? I know, Christian, you're still waiting on those answers. I'm going to pull those up while y'all are looking for your next question. Give me 1 second.
Yeah, I'm all good. Did everyone else get a radical to start number 1? I got like a weird radical.
What do y'all think, guys? Did y'all get a weird radical?
I put it in decimal form, so I got 16.6, but
Yeah, I mean I did that too, but it was just originally a
It
radical.
looked odd.
Yeah, I did.
Okay. I don't have the work written out along the way. I'll double check that that's the answer. Give me just a second. Let me get this, and then I'll see if that's the right answer.
I was about to ask if we could go over that one.
Yeah.
Yes, ma'am.
Okay. Let me get this real quick. Sorry, it's not hard to get these answers. I'm getting this just tedious. Hang on. Cut, copy, cut, copy, cut, copy. So.
Thank you for that, by the way.
Mm-hmm. All right. Maybe, possibly. Come on. I don't know what he's talking about today. All right, I'm going to do 16, and then I'll go back to cutting and copying in some more. All right, 16. First, let me just see if what y'all got was right. 16.
No, it was 1.
Oh, number 1. I'm sorry.
We
I
got 16.6.
16.6. Thank you. Yes, 16.6 is correct. And let me share the screen again. All right, number 1, to find the measure around your answer. So MN, oh, come on. That's your X. So the quickest way to do that is what? What method did y'all use, Anna and Christian?
Pythagorean.
Yeah, Pythagorean. MN is the hypotenuse. So by itself on one side. 7 squared. When I write on these kind of documents, my pen does not like to cooperate. I'm sorry. Okay. 7 squared plus 15 squared. So 49 plus 225. And the square root of that. Yeah. Braden, you good on that?
Yes, ma'am.
Yeah.
Solving it out, I got 16.6. Yeah, I got 16.6.
Perfect. All right. Other questions?
For number 2 and 3, when we find the angles,
Mm-hmm.
are we gonna use like sine and cosine and stuff for that?
The inverse of sine and cosine and tangent. The very last tool, I think it was was it 7 or 8? I forgot how many we listed. But the very, very last tool on those notes that you took, that's the inverse. And you always use that if you don't know angle measures. Like, now you can see the whole worksheet down here. Like, number 4, you wouldn't need it because you could use triangle sum to get angle P. Number 5, you would need inverse because you only know the right angle. Number 6, you would need it because you only know the right angle. Number 7, you could do triangle sum again because you know that 51 you can just subtract. That makes sense, the difference of when you need it and when you don't?
Yeah, but how do you find out like if it's cosine, sine, or tangent?
Okay. So that depends on which angle you're trying to find. So number 2, if you're trying to find angle M, there's your perspective is angle M. I told y'all it helps me to circle it. And if y'all want to bring colored pencils or something to do this color code and stuff, that I do on Math Lab. That's absolutely fine. So my blue angle M that I'm looking for, from that angle, what is 7? Opposite, adjacent, or hypotenuse?
Adjacent.
Adjacent. Okay. What is 15?
Opposite.
So you use the numbers that they give you, see what parts of the triangle it is, depending on the angle you're trying to find. That's first. And then you think about your trig functions. Which one of the functions uses opposite and adjacent?
Wait, that's tangent.
So you're going to say the tangent of M equals opposite over adjacent. So for this triangle, what would be your fraction over here?
15/7.
And then in order to get M, that's what we're trying to get. That is when you're looking for an angle. So you use the inverse function. So you go to the calculator, second tangent, 15/7.
65.1.
Just do 65 because you're already rounding up one time. Don't add the 0.1, but
Okay.
64.98, whatever. So round up to 65. So angle M, remember, that's why I kind of like the circle thing because it helps me remember too which angle I was looking for. So 65. Can't write on this kind, but is up there. So angle M, 65. For angle N, you have options because now your triangle looks like number 4 because you know the 90 and you know another angle. So you can, to get angle N, you can just subtract from 180. You can say 180 minus 90 and minus 65, and that'll give you angle N. You can do trig inverse again if you want to, or you can just subtract.
Answer is 25 degrees.
You got it.
I have a question.
Does that make sense?
Yes, ma'am.
Okay. Yes, Christian?
Number 6, I'm working that one out. And I got, for the UT, I used Pythagorean theorem. And I ended up getting a number that was like 22.97, right? So just to round to the nearest tenth. But if I round to the nearest tenth,
Makes it the
that'll
same.
become 23. So
Let me see how they left it. The answers are here, so just don't copy answers. But let's see, number 6, 20. They got 20. I got 21 point something. Did you square something wrong, maybe? Let's see. So it'd be 23 squared equals 7 squared plus x squared or whatever, right? Is that how you... So,
oh, it's a 7. I thought it was a 1.
oh, okay. That would change
That's
it.
what I did wrong.
But that's good that you noticed that because that's using your logic. Wait a second. A leg can't be the same as the hypotenuse. That doesn't work. So it's good that you noticed that.
Yeah. What I'm thinking about.
Could you help me on number 21?
Sure. Okay. So the angle of depression. Whoa. I was trying to make it bigger. I made it too big. Sorry. Oh my goodness. Can you see it? Let's see. Let's zoom out a little bit. Come on.
Miss Wynn, did you ever fix your computer or no?
It finally started working when I was in journalism yesterday, but I didn't have any idea what. Maybe it was just tired. I don't know.
Did it, when you turned it back on after I shut it off, did it start working again or no?
It did.
Okay,
Yeah.
cool.
I only signed into that one website for journalism, so I didn't try other things, but
Yeah.
that website worked. So
Yeah.
And I wasn't trying to cast. So hopefully for Mr. Sickley, it was casting correctly.
I don't think he had to cast anything, so
Well, hopefully tomorrow it'll cooperate. All right, 21 angle depression from a 320 building to the 200-foot building is 55. So they're showing you that dashed angle up there is 55. How far apart are the buildings? You're trying to find X. All right. So in this problem so far, there's no triangles. That's not good. The whole chapter is about triangles. So you need to make a triangle. And so you have to piece together this information to get your triangle. That's why I was trying to make it bigger so we could make a triangle. Everything's labeled on the picture, so we really just need the picture. All right. So here's our X down here at the bottom. And if we know the tall building's 320 and we know the short building's 200, we can find out the difference in the buildings, which would be like right there. How much would that be?
How would you, is that like the outside angle thing? Or-
No. This one's, it's really just subtracting. If one building's 320 and one's 200, how much taller is the big one?
120.
Yeah, so that side, the pinkish there, that would be 120. So there's one side, and we can draw this side, which is our X that we're trying to find. So now we've got a little triangle in there. Does that make sense?
Yes.
Okay, so I'm going to draw that triangle down here so I can make it a little bigger and label what we actually know. So we got this 120 is our X. Now they told us that 55, but that 55 is right here. That's 55.
Okay.
So our angle that's related to that 55 is up here. How could we find that angle?
95 minus 55.
Or 90 minus 55, yes.
That's what I meant.
I thought so. So how much would the top angle of our triangle be?
35.
Mm-hmm. Is this making sense how I'm pulling this out of what they gave us?
Yes.
Okay. So 30. Sorry, this one just, my writing's not as neat. So here's our triangle. And so now this looks like a lot of the problems you already had, where you're just, you know, some of the pieces and you're trying to find some piece that's missing. If we know that 35-degree now, and we're trying to find X, what part of the triangle is X as it relates to the 35?
Opposite.
Mm-hmm. And we know 120, what part is that?
Adjacent.
Mm-hmm. So which trig function?
Tangent.
Tangent. Mm-hmm. The tangent 35 equals opposite over adjacent. So it's X over 120. Does that make sense?
Yes.
Yeah. All right. I'm going to show you, just because everybody's brains work differently. I'm going to show you how I've had some students solve it. My brain sees it this way, but I've had some students who, instead of that pink triangle, they make this triangle. They say, oh, well, this is 120. So then they have this 55-degree angle. So here's their triangle. 55, 120. And then this is their X. Can you see the difference in the red and the pinkish?
Yes.
So either way, though, if you set up your trig function, you should get the same answer. It just depends on how your brain orients your triangle.
Okay.
But when you punch that in a calculator, let's see. I don't know what you get, so let me see.
Yeah, 84.1 or 84 even.
84 even. Yep. Because 84.02, so you just round to the 10th. So they're about 84 feet apart.
That's what I got. So
Does the process make sense?
yes.
Good. Other questions?
Number 13. Like a few of those from that section.
Let A be in the cube, right? Approximate the measure of angle A to the nearest 10th. Oh, these are just the punch in the calculator.
Oh, really?
Remember, if you're looking for the angle, because approximate, oh, where's my pen? There we go. Approximate the measure of angle A. So you're looking for the measure of an angle. That's when you use the inverse function. So basically, sine inverse and 0.36.
So I'd get 21.1.
Yes.
Awesome.
Other questions?
If Anna didn't have any, I got one.
Anna or, well, Christian left, but Anna, you got anything or need anything? Oh, she left.
Okay, cool.
All right. What's your question?
The back page. What number was it?
I don't know.
Number like 22 through 24.
23 and 24?
22 through 23. Wait a minute. No. Shoot, I'm sorry. Let's just start with number 22.
Have you tried it?
No.
No. All right, look at it. Read what's given and try to process it. And let's see where we go from there. I'm going to read it too because I haven't reread it. All right. So what are we trying to find?
The distance across the bridge.
All right. That would be the kind of darkened line, right?
Yes, ma'am.
Like all this.
Yeah.
All right. So they've given us triangles to help us find that. And they're all the same, all those measurements in there they're giving us. So we can pick any of those triangles to work with just because we only work with one at a time, really. And if we find out about that one triangle, we can repeat that length how many ever times to get us all the way across the bridge. Does that make sense?
Yes, ma'am.
Okay, so I'll just pick the one in the middle. Here's our triangle. It's a right triangle because a bridge would be flat so that it's stable. We know that the kind of the height of the bridge, that leg of the triangle is 52. We have a 32-degree angle and a right angle. If we want to find the length across the bridge, what we're interested in is this piece down here, right?
Yes, ma'am.
How can we find that?
Well, we know that the height is 52 feet and that the angle is, one of the angles is 32 degrees. Or we know two of the angles, so we can do, let's add those angles. So it'd be 180 minus, open parenthesis, 90 plus 32, closing parenthesis. You get 58 is your top angle.
Yeah.
So you know the angles. Now you just need to find your other measurements. You already have one with I don't know. I don't know where to go from here.
All right. From what they gave us, the 32 angle. Let's pretend like our little person's there, okay? So here's, oh, I was trying to change color and I didn't. Sorry. Here is our angle that's kind of like our perspective down there, okay? The 32. From that 32, we know 52. Is 52, is that opposite, adjacent, or hypotenuse?
To the 32, it is opposite.
Opposite. Okay?
Yes, ma'am.
The darkened red on the bottom, what we're trying to find, this X down here, what part is that according to the 32?
Adjacent.
Adjacent. All right. If we have opposite and adjacent, what trig function is that?
That'll be tangent.
Because tangent.
Second tangent.
Nope.
Whoa.
Are we looking for an angle?
No.
Okay.
So that's
Only do second tangent if you're looking for an angle. Okay.
yes, ma'am.
So in this one, we know the angle, tangent 32. We got that part. Is opposite over adjacent. How much is the opposite?
52 feet.
And the adjacent is what we're looking for. So our X. So how would you solve this equation up here?
I don't know. I always have trouble on this one.
Okay, there's two ways to think of it. You can think of get X out of the denominator. That's called clear the fraction. Or you can cross multiply.
Okay.
Which way do you want me to talk you through it?
Cross multiply.
All right. If you cross multiply, you need two fractions, right?
Yes, ma'am.
So anytime you have something that's not a fraction, you can put 1 underneath because it doesn't change it. With me?
Yes, ma'am.
So if we cross multiply, we do tangent 32 times X equals 1 times 52. How do we get X by itself now?
Divide.
By
Divide by 50. Or no, divide by tangent 32 times X.
just tangent 32 because we want to leave the X. We want these to cancel out, right? Because we want X by itself. So then divide by tangent 32 on the right.
Okay.
That's just calculator.
83.2.
Yes.
So X equals 83.2. And that's it.
That's not it, because that's our dark red piece of this one triangle, right? So if it was just that one triangle, that red highlighted triangle as the problem, you'd be done. But think about how the word problem, they want the distance across the bridge. So how many pieces that are 83.2 long do we have?
5.
Look again.
1. Well, including the X we just found?
Yeah, because we got to get all the way across. So here's 1, 2, 3, 4, 5, 6 of them, right? To get all the way across the bridge.
Yes, ma'am.
So we're going to multiply that times 6. Hang on, Cruz, just a minute.
499.2.
All right. Questions about that one, the process of that one?
No, ma'am.
No? Okay. All right. Have you looked at 23, 24? Not yet.
Or I looked at number 24. I think I do 24.
Hang on. Let me solve his dilemma. I'll be right back.
Yes, ma'am.
What's wrong, Okay. We're just stretched. There you go. I think there's just need this one. Let me get the other one. Glasses. They're a little bit smaller. Yeah. All right. How's it looking on 23?
Confusing, sort of. So like I know the length is 16 and the vertical rise. So like I'm gonna draw this out.
Good idea. I'm going to label it on the screen, but
I'll just label it on that one triangle we already have.
you can draw it out. It's fine. I was just going to say, so I don't have to pull up a separate screen, I'm going to label it here, but you can draw a separate one. It's absolutely fine. Bless you.
Thank you.
Mm-hmm. All right. You got it labeled?
Yes, ma'am.
Okay. Does it look like this? 16 on the hypotenuse, 14 on the little leg, and X on the bottom?
Yes, ma'am.
All right. So first we need to find X. If you know two sides of a triangle, of a right triangle, how can you find the third?
Use the tangent, the second button tangent deal that we've been doing.
No, that's for angles.
I know,
We'll need that in a minute. But right now we need a side. We need the horizontal distance, that bottom
we can
side.
Pythagorean theorem.
So do that first.
So squared equals 16 feet squared plus 14 inches squared.
No.
Okay.
The hypotenuse is 16, right?
Yeah.
And we're doing inches and feet. I don't know if they change it over or not. I bet they do. Let's make it all inches because see how it's got feet and inches.
Yeah.
And since this wouldn't be an exact measurement in feet, it'd be a decimal thing. Let's make it inches. So how many inches is 16 feet? How would you figure that out?
16 divided by 12.
Not divided.
Multiplied by 12.
Yeah, because if you have feet, 16 feet is a whole lot of inches, right?
So 192 inches.
So I'm going to do this just so we remember there was a 16, but 192. So now we've got all the same units. So we'll be sure when we're measuring we got the right thing. Okay.
Okay.
So we did hypotenuse squared. So That by itself equals 14 squared plus x squared. Be very careful when you set up Pythagorean theorem. The hypotenuse, or the longest length, always goes on the left by itself. Always.
Okay.
A lot of people that miss it for that reason, that they didn't do it by itself.
Yeah.
So it's big, but I got
2, 3, 36,864.
I can't write an 8, but yes. Equals 196 plus x squared. So you already have that number in your calculator. Just do minus
Yeah.
36668. And then do the square root of that.
Squared. It's 191.5.
So that is the first part of the question. Estimate the ramp's horizontal distance. So x on the bottom here is 191.5.
Miss Wynn,
Yeah,
do you mind if I go blow my nose real quick? I'm super stuffy.
you're good.
Thank you. Alrighty, I'm back.
All right. I was working on Christian's homework answers to check. So let me get the screen back up. Oop, cancel. Sorry. Let me. There we go. All right, so we got the length, the horizontal distance down there, the 191.5. Now we need to, in that same part, we wanted the ramp's horizontal distance and the angle. So let's get the angle. I'm going to get a different color because there's a lot of blue going on over here. All right, so the angle is down here. This angle is what we're trying to get. If we're looking for an angle, which of the tools do we use? Last but not least,
The second tangent button.
yeah, there we go. Okay, the inverse functions. So in this triangle, let's not use the decimal because that weakens the answer. So if we're looking for this purplish angle down here, that's our perspective, that's our angle. I want to use this 192 and this 14, okay? From
Yes,
that
ma'am.
from the purple angle, the 14, what part of the triangle is that?
The opposite.
Mm-hmm. And the 192, what part is that?
That is your hypotenuse, but it can also be an adjacent technically.
It could, but you usually only use the words opposite and adjacent on the legs.
Okay.
That way, because the hypotenuse is always the hypotenuse, no matter which angle you're looking at.
Yeah.
So that's why they usually use opposite and adjacent to talk about the legs. Does that make sense?
Yes, ma'am.
Okay. So if we're looking for that angle and we're using opposite and hypotenuse, which of the trig functions uses opposite and hypotenuse?
The tangent.
No.
Oh,
It's
wait.
the old hippie
It's sine.
sine. So the sine of our angle we're looking for, I'll put A because it's an angle, okay? The sine of our purple angle down here that we're looking for equals opposite over hypotenuse. For this triangle, those numbers would be 14 over 192. You with me?
Yeah, I got 4.2.
Let's see. I haven't punched it in yet. Let me see. You're skipping ahead. I'm trying to describe it, and I don't know that you're there. Let's see. 14 divided by 192. 4.2 is correct. So this angle down here, I can't write it in there, but 4.2 degrees. And then it says, does this ramp meet the Uniform Federal Accessibility Standards? Well, they
Yeah.
told us up here. Why does it meet?
Because it's less than 4.78 degrees.
You got it.
It's a lot of work for one little answer.
It is. But I guess they want you to see that this is a real life thing. I mean,
Yeah,
if
like people
if
actually
I was in a wheelchair, I would be interested to know that I could actually be able to go up this ramp and not, need to be muscle woman to do it. It's the same. I don't think in your class we got a chance to do it, but there was one about a stage, and sometimes the stage where actors perform is slanted. It's called a raked stage. And so it's got to be at just the right angle also, or else the actors will go tumbling into the audience. So it's pretty important. All right. Well, I am going to sign out, but if you have more questions later, you can email, okay?
Yes, ma'am. Thank you.
You're welcome. Have a good day.
You too.
Thank you.